So today in class, we talked about some quadrilaterals and things like that. I want you to now do the same idea, but you're going to be looking at triangles, okay? So when we look at what we've got going on our page here, by the way, you can print this page out. It should be in the Google Classroom stuff along with this lesson. So you should have stuff like this, and basically we want to look at each of these. Here's what right triangles are. Here's what's not right triangles, and write a definition. So right now, based on this, the video is going to pause. Type your definition of what you say a right triangle is. Go. Okay, so a right triangle. Notice that we have a 90-degree angle here. That's what the box means. A 90-degree angle there. This triangle has no 90-degree angles. That one has no 90-degree angles. That's not even a triangle. So a right triangle is a triangle with one 90-degree angle. Okay, so there we go. There's our right triangle. Very simple definition. Try the next one. Define an acute triangle. Go. Okay, acute triangles. Well, we already talked about what acute angles were. So acute triangles are triangles that have acute angles. Notice there's a right angle there. There's an obtuse angle there. So these are triangles with all angles acute. Whoops, sorry, I got annoyed. Triangles with all angles acute. Okay. Next one, obtuse triangles. Think about this one very carefully. Go. Okay, so obtuse triangles. We have one obtuse angle, one obtuse angle. Notice you have two obtuse angles here, but that's not a triangle. No obtuse angles and a right angle, still not obtuse. So an obtuse triangle is a triangle with one obtuse angle. Okay, so we've got our basic triangles. Let's go look at some more information on triangles. Last time we were defining triangles based on angles. Now we want to look at them based on sides. So scalene triangle. Try this one out. These are scalene, these are not. Go for it. So what I notice is this triangle, all sides are equal. That's why they all have the same mark. This side, two sides are equal. This isn't even a triangle. So first of all, to be a scalene triangle, we have to be a triangle. And no sides equal, no sides equal, no sides equal. So that kind of tells me it's a triangle with all sides different measures. Okay, so each side is going to have a different measurement to be scalene. If I have two equal sides, it's no longer scalene. If all three sides are equal, it's no longer scalene. So let's try another one. Again, looking at sides, an isosceles triangle. Go for it. This is probably something you already knew anyway from previous classes. Isosceles triangles are triangles with two sides congruent. Make sure you use congruent, not equal, because we're talking about sides here. Okay, there are some nice things about isosceles triangles. Whoop, that one's not isosceles. What's it doing here? That one's bad. That should have 2 marks on it. Okay, so there's our isosceles triangles. We knew this one already. Some things that we also know about isosceles triangles, the different parts. So these are our legs. The two sides that are equal are the legs. Now, legs don't always have to be going up and down. In this case, here's our legs. Okay. The non-equal side is known as the base. And be careful, in mathematics, base does not always mean bottom. In this case, the base is here. So that means these two angles are the base angles. And again, they're the angles at the base. So in this case, the base angles are here and there. And in this last angle is known as a vertex angle. So that's known as the vertex angle. And that's the angle between the two congruent sides. Nice thing about isosceles triangles. We've got a theorem about isosceles triangles. I'm going to put this here, a nice theorem. Base angles of an isosceles triangle are congruent. It's a nice theorem to remember. It's going to come in handy for us when we're trying to solve for triangles and things. So the base angles of an isosceles triangle are always congruent, which means if I know the angles are congruent, I know I have an isosceles triangle. Okay, great. Let's look at some more stuff. A couple more things about triangles, and then I'll let you go for tonight. So, next one, median of a triangle. Now, median is a word you've heard before. If you think back to your algebra class, you talked about mean, median, and mode. So you had mean, median, and mode. And mean, median, and mode, basically you said the mean was the average, the median was the middle number, and the mode was the one that showed up the most. Well, this idea of middle number is going to be interesting. Now, mean doesn't mean middle because it's got to be a different type of thing. So let's look at this one, the medians of a triangle. What do you think the medians of a triangle are going to be? Go ahead and type your definition. Even if you think it's wrong, type it. Type what you think it is, comparing these medians, these two medians, to these two not medians. Go. Okay, so one thing to know about medians, they're segments, right? So medians are segments, first of all, that, and look where they're connecting, from one angle to a side, one angle to a side, not two sides. This one's connecting an angle to a side, but a little different. Look at the side that's connecting to. These two are the same, those two are the same, these are not the same. So a median is a segment that connects a vertex to the midpoint of the opposite side. So we're connecting from one angle, any vertex, going to the opposite side, hitting at the midpoint, from an angle to a midpoint. The segment is the median, okay? Not the midpoint. Midpoint's a point. The segment is the median, okay? So make sure you get that and understand that one. That's going to be an important one. Let's take a look at one more, and then we'll let you go. Altitudes of a triangle. This is a word that you may know already. So give me what you think an altitude is going to be. Go. So altitudes of a triangle, again, they're going to connect from a vertex to a side. Not here, so that's not an altitude. That one looked like a vertex, but oh, look at that. That's the connecting to the middle. So that's a median. This one's cutting the angles in half. So that's an angle bisector. And here we're connecting from vertex to a side, make a right angle. Vertex to a side, make a right angle. Even though it's not really going to the side, it's going somewhat like that. Vertex to a side, even though it is a side. Vertex to a side. So an altitude is a segment that connects a vertex to the opposite side and is, here's the key, right angles, perpendicular to the side. Okay, so for an altitude, the key is that you got to be perpendicular to that side. For a median, the key is that you got to be to the midpoint. So that's the differences between altitudes and medians. Okay, good job, good taking notes. You've answered your questions. I will see you tomorrow.